Hello everyone, how are you all? I hope you all are fine and safe. Well, again, welcome back to Quant Coffee, and I'm Aman, just welcoming you all to a new amazing video. Well, it's been a long time, but I'm sorry, I was busy somewhere. Okay, but it's alright, I'm back. And as I uploaded a video on philosophy, and again, I'm sorry if you guys find it slightly like personal. So like if you found it something like that, so I'm really sorry about that. But that's not my intention was. I just want you to just look at the truth. Okay, so now we are back with mathematics. And here what we are going to do is, let me just write that down here. So we are going to evaluate an integral from negative, oh I'm sorry, from 0 to pi of ln of 1 minus cosine x times ln of 1 plus cosine x dx. So this integral, it looks quite easy at first, but again, it's my observation, if you got some natural logarithms inside as an integrand, and if you got more than one, so be careful, it's gonna be difficult. Okay, so yeah, this is what we are going to evaluate in this video. And again, this is, we are not evaluating this, we are learning from this, because each step is gonna teach us a lot, right? Okay, so yeah, I have written what majorly what we are going to use in the evaluation of this integral. So firstly, maybe you cannot see this directly, but yeah, I will use them and tell you about it later on. So let me tell you just slightly here. Cosine of x is represented as e to the ix plus e to the negative ix over 2. And the Maclaurin series of ln of 1 minus z is minus of the infinite sum as n goes from 1 to infinity of z to the n over n. And as well as for ln of 1 plus z, that is the infinite sum as n goes from 1 to infinity of negative 1 to the n plus 1 times z to the n over n. And third one, this integral from negative pi to pi, right, or from negative a to a could be anything, e to the I k x dx equals, if k equals 0, then this evaluates to 2k, and if k is not equals 0, this evaluates to 0. You can do it by your own, you just have to take this thing as let you have to use up here, or else you can do this directly. You just have to divide this ik with the antiderivative of this. So yeah, you can do that. And then we're having Dirichlet Eta function. I'm sorry about that. Dirichlet Eta function is represented as the Dirichlet of s eta of s is represented as the infinite series as n goes from 1 to infinity of negative 1 to the n minus 1 over n to the s. And again, the relation between Dirichlet Eta function and the Riemann zeta function is eta of s equals 1 minus 2 to the 1 minus s times zeta of s. So yeah, it's just an overview what majorly we are going to use, and rest of the things would be elementary, right? Okay, so I think we should begin from here, because this is gonna take quite good amount of time. So firstly, let's just begin plugging this here and here. So let's assume that our before that, we can do this. Since we are integrating this from 0 to pi, I can do this from negative pi to pi, and since cosine of x is an even function, so I can divide it, like I can multiply it with half. And this is exactly what this integral we are going to evaluate it. So yeah, and why we did that, I will tell you, because let me tell you here, because of this one, because we have to use this property. How amazing is that? Okay, so the integrand is ln of 1 plus let's just 1 minus cosine of x times ln of 1 plus cosine of x dx. Now let's replace 1 over 2 integral from negative pi to pi ln of 1 minus e to the ix plus e to the negative ix over 2 and times ln of 1 plus e to the ix plus e to the negative ix over 2 dx, right? And now we are just going to solve this and this too. So that's gonna give us integral I equals half times the integral from negative pi to pi ln of 2 minus e to the ix minus e to the minus ix over 2 and times ln of 2 plus e to the ix plus e to the negative ix over 2, right? Yeah. And now we're just going to use the basic logarithmic identity for this one and this one. So that's gonna give us integral I half times integral from the negative pi to pi of ln of 2 minus e to the ix minus e to the minus ix minus ln 2 and times ln 2 plus e to the ix plus e to the minus ix and minus ln 2, right? So yeah, so far we did nothing but just use this thing and the basic logarithmic, natural logarithmic identity. Okay, right? And then what we are going to do is, okay, so now we are just going to assume that define, wait a second, so yeah, okay, and now just have a look at this thing and this one also before defining this. 2 minus e to the ix and minus e to the minus ix. Well, what can I do with this? Well, we can go with this one. We can think that 1 minus e to the ix and times 1 minus e to the minus ix. Just look at this. Because when you expand this after this multiplying, like let's do it. So 1 times 1 is 1. Minus e to the minus ix minus e to the ix, and that's gonna give us e to the ix times e to the negative ix is 1, and that is negative times negative, which is positive, so that's gonna give us positive 1. So 1 plus 1 is 2, 2 minus e to the ix minus e to the minus ix. So yeah, this is equal. And similarly for 2 plus e to the ix plus e to the negative ix. So that's gonna be written like this, 1 plus e to the ix and times 1 plus e to the negative ix. So we are just going to replace this thing with this one and this thing with this one. Let's do this here and here. So just let's just do that. And so we could have two logarithms, right? So that's I equals 1 over 2 integral from negative pi to pi, and we can write that as 1 minus e to the ix and times 1 minus e to the minus ix and minus ln 2 and times ln 1 plus e to the ix 1 plus e to the minus ix minus ln 2 dx. And now again, just using the basic logarithmic identity, So we can split this into natural logarithms, and with let me just do it here. So I comes out to be half integral from negative pi to pi. That's become ln 1 minus e to the ix plus ln 1 minus e to the minus ix minus ln 2 and times ln 1 plus e to the ix and plus ln 1 plus e to the minus ix minus ln 2 dx. Right? Yeah. So yeah, this is what we are having. I hope you guys are not having any sort of problem here. Okay, and now we are just going to define something. Let me just erase this stuff. Okay, so let's define a of x as this integrand, like the part of integrand, that is ln of 1 minus e to the ix plus ln of 1 minus e to the minus ix and minus ln of 2. Okay, and so for bx and this one we're talking about, so ln of 1 plus e to the ix plus ln of 1 plus e to the minus ix minus ln 2. Right? Okay. Yep, it's fine. And then what we are going to do is we are going to use the Maclaurin series. So the Maclaurin series of, let me just write that down here again. Ln of 1 minus z was negative. The infinite sum as n goes from 1 to infinity of z to the n over n. And for ln 1 plus z is the infinite sum as n goes from 1 to infinity of negative 1 to the n plus 1 z to the n over n. Right? And we are having in a of x, we are having e to the x and e to the minus x as z, like for this expansion. And in b of x, we are having e to the x ix and e to the minus ix as z for this expansion. And now we're just going to play around with that. Right? Let's just replace our a of x and b of x in terms of these two infinite sums along with their z's. So let's talk about a of x firstly. So when you replace e of ix here with z, so that's gonna give us negative of the infinite sum as n goes from 1 to infinity. Well, we can do this both at once. And we can do that like this. E to the I n x over n and plus e to the minus I n x over n. And we are having negative ln 2. So this is your a of x. Right? And if we talk about b of x, so our b of x, let me just do it right here. B of x is the infinite sum as n goes from 1 to infinity of negative 1 to the n plus 1 times e to the I n x over n and plus e to the negative I n x over n minus ln 2. Yeah, that's fine. That's totally fine. So let's just replace these two things. Yeah, we have replaced. Replaced, and we have shown that. And now we will consider that ln 2 as c, and so for this. Yeah, we are going to just play around with that. Okay, yeah. And again, we are just going to define something, and for that, let me just write that down. So our I was um, that was, what was that? Wait a second. Um, this is our a of x times uh, b of x, right? And yeah, it's 1 over 2 integral from negative pi to pi a of x times b of x dx. And if we talk about a of x, well, I have written those things in my notebook, so we don't need to worry about that. Let me just erase all the stuffs. Okay, so now yeah, we are going to assume something, define something, or let firstly c equals ln 2, right? And s of x equals minus of infinite sum of e to the I n x over n plus e to the negative I n x over n. So this is our assumed s of x. And if we talk about the t of x, so that was, I'm not including ln 2, be careful, because if I include that with negative sign, so that's gonna give us a of x, right? So be careful about that. And equals 1 from infinity to infinity, I'm sorry about that. And then negative 1 to the n plus 1 of e to the I n x over n and plus e to the negative I n x over n. So this is our assumed t of x. And if we try to just write about a of x from these two things, so that's going to give us s of x minus c. And if we talk about b of x, so that's going to give us t of x minus c. So I just want, if you are writing these things, so I just want you to write this down, because this is really important, right? Okay. And now let's talk about a of x times b of x. Let's just multiply these two things separately. So s of x minus c times t of x minus c. So that's gonna give us s of x t of x and minus c times s of x minus c times t of x plus c squared, right? Yep. And since our integral that we are ought to evaluate is half times the integral from negative pi to pi of a of x times b of x, it means we have to integrate this thing, right? Yep. And how cool is that? Wait a second. Oh, okay, I'm sorry. I'm not including negative here, I'm sorry. Not including negative. So that is negative. Because when you place negative here, so that is where our assumption would satisfy. So a of x equals negative of s of x minus c. So that's become equals negative, and this becomes positive. I'm sorry, I'm not including negative. I'm just taking the positive, like this infinite sum. Okay. And now if we take a look, I equals 1 over 2 integral from negative pi to pi of, so that was from here, we can say it's a of x times b of x. And that is what we did here. So this is our result for a of x times b of x. So let's just replace it with that. Integral from negative pi to pi of negative of s of x times t of x plus c times s of x minus c times t of x and plus c squared dx. Okay, now here comes the important part, and for that let me just erase this one. Okay, so what was our s of x? Well, there are four different like functions, and we are just going to separate all these four functions as an integrand, right? Basically, that's gonna give us 1 over 2, negative of 1 over 2 integral from negative pi to pi of s of x times t of x dx, and plus c is a constant, integral from negative pi to pi of s of x dx, and minus c is a constant from negative pi to pi t of x dx, and c squared is a constant. Yeah, like I hope you are getting what I'm trying to say, what I'm trying to just what I'm trying to say here, right? So our assumed s of x was something like this: e to the I n x over n plus e to the minus I n x over n. So as I told you that since our series is not beginning with 0, it's beginning with 1, hence n cannot be 0. So if we go through this formula, so here your k is n. So basically that is, well, 1 over n is a constant, right? So basically this is what it is all about. And since k is not equal to 0, so this integral equals 0. So basically if I'm integrating s of x from negative pi to pi, d of x is 0. And similarly for t of x also, because that is also a function something like that. So hence these things equal 0 and this one is also 0. We are left with only this one and that last one. Isn't it amazing, guys? Right? Okay, so now let's just talk about those two integrals. So basically what we are having are I equals negative 1 over 2 integral from negative pi to pi of s of x times t of x dx. And if we talk about that one, so c squared integral from negative pi to pi d of x. So this is gonna be pi c squared. Oh, I'm sorry. It's c squared by 2. I didn't divide it with 2. And yeah, I'm sorry about that. I'm sorry. So that's gonna give us pi c squared. And now we have to talk about this one. So I is, like, for now it's finally negative 1 over 2 from negative pi to pi s of x t of x dx plus pi c squared. Right? Yep, that's amazing. And now we're going to talk about s of x times t of x. And again, our s of x was this one, e to the I n x over n plus e to the negative I n x over n. And our t of x was negative 1 to the n plus 1 e to the I n x over. Let's talk about, let's consider this as m. Well, it's just in this variable, so that's not gonna bother us. But for our convenience, I am x and over n and plus e to the negative I n x over n. So yeah, and now we are going to talk about s of x times t of x. Basically, we are just going to multiply this infinite series with this one. Let's do this on that board. Hence guys, Maclaurin series, Taylor series, infinite series are very important because that makes our life easier. So if we talk about s of x times p of x, so as m goes from 1 to infinity of e to the I m x over m plus e to the negative I m x over m, and times the infinite sum as n goes from 1 to infinity of negative 1 to the n plus 1 and e to the I n x over n plus e to the negative I n x over n. Right? Okay. So finally we can write this as the infinite sum, since m is equals from m equals 1 to infinity and times n equals 1 to infinity, and that's gonna give us negative 1 to the n plus 1 over m times n, and times e to the I m x plus e to the negative I m x, and times e to the I n x plus e to the negative I n x. Since if these two series are going simultaneously with each other, so be careful that m minus n equals 0 and m plus n is not equal to 0. Right? Okay, so I can write this as the infinite sum m comma n greater than equal to 1. Actually, I'm sorry, m and n both are greater than equal to 1, and with this thing, oh, let's talk about let's multiply these two things firstly. Let's not write the summation sign because it is going to take some space which we are not having. Okay, so if we talk about this one, let's multiply. So that's gonna give us e to the I as common m plus n x, and then plus e to the negative I common m minus n x plus e to the negative I common m minus n x and plus e to the negative I m plus n x. So after multiplying these two parentheses, we are having this thing. Let's just do this. Just remember that. Let me just write that down here somewhere for your convenience. So I was 1 over 2 integral from negative pi to pi s of x t of x dx plus pi c squared, and c was ln2. Okay, now we are good to go to erase this thing. Okay, so let's just write this thing here. So s of x times t of x equals, we can write this as m comma n is greater than equal to 1. Right? I've just combined these two infinite sums with each other. Negative 1 to the n plus 1 over m times n, and let's just write these all things. E to the I m plus n x plus e to the I m minus n x plus e to the negative I m minus n x and plus e to the negative I m plus n x. Since these two things are going simultaneously, like m and n, so m and n plus n is not equal to 0, but m minus n is 0. And what we were finding for the integral for this, so integral from negative pi to pi of s of x times t of x dx equals integral from m comma n greater than equal to 1 negative 1 to the m plus 1 over m times n integral from negative pi to pi e to the I m plus n x plus e to the I m minus nx plus e to the negative I m minus nx plus e to the negative I m plus nx dx. So from here, since m minus n is 0 and here it's 0, but this is not equal to 0 and this is also not equal to 0. So for not equal to 0, like k is not equal to 0, so this one and this one is 0 and this one is 2 pi and 2 pi. This is what we have to understand if we integrate this thing. And I'm not gonna do this properly step by step, but yeah, I would request you to solve that down, and maybe you can use this thing. But you can do that by yourself, even if you don't know about this thing. So basically, what we are having integral of from negative pi to pi of s of x times t of x dx comes out to be the sum. Well, since both things are equally going to infinity from 1 simultaneously, so I can write this as only 1, and I'm just going to replace all the m with n itself. So n equals 1 to infinity, negative 1 to the n plus 1 over n squared. Since m is n, so n times n is n squared, and we are having 2 pi plus 2 pi and plus 0, so yeah, that is 0. Now from our I that we have done in our last time, so that was I equals negative half times the integral from negative pi to pi of this thing. Our I was negative half negative pi to pi of s of x times t of x dx plus pi c squared. So this is what we had, and now we can replace this thing with this integral. So that's gonna give us I equals negative half of the sum as n goes from 1 to infinity of negative 1 to the n plus 1 over n squared and times 4 pi, and plus when we can replace c with ln 2, so that's going to give us ln squared of 2 and times pi also. Yep, don't forget about that. So this 2 cancels out this as 2 pi, so we are having negative 2 pi the sum as n goes from 1 to infinity, and since n plus 1, and we can replace that with n minus 1 because that is not gonna change anything in the infinite series at all. So we can replace n plus, because we are not talking about n, we are talking about n minus 1. So we are having a gap of n. So eventually that's gonna give us the same infinite sum. So from negative from 1 to infinity of negative 1 to the n minus 1 over n squared plus pi ln squared 2. And if you look closely about this thing from here, if you might if you can see this, so this is when you replace s with 2, so that is the same thing which is just written over here. So this is the Dirichlet Eta function of 2, right? Now this is going to be our final board here on which we are going to work for this integral. Or maybe we could take that board because still we have to do quite things. So our I is negative pi Dirichlet eta of 2 and plus pi ln squared of 2. Well, from this formula, that is, let me just, Dirichlet of S equals 1 minus 2 to the 1 minus S and times the Riemann zeta of S. This is a formula, and if you want, guys, I would just bring up a proof for this one, and I would be really exciting. I'm exciting about this. So when you replace S with 2, so Dirichlet of 2 comes out to be 1 minus 2 to the 1 minus 2, Riemann zeta of 2. Riemann zeta of 2 is pi squared over 6. This is called the Basel function. So, and I have uploaded one of my videos on this, so you can check that out if you want. And this finally comes out to be this Dirichlet eta of 2 is this is going to be 1 over 2, so that's going to give us pi squared over I think it's 12. Yeah, wait a second. Yeah, I think, yeah, it's right. So if we just plug that over there, so I equals negative 2 pi into pi squared over 12, and wait a second, wait a second, it's negative 1, so it's 1 over 2, and it's 1 over 2 pi squared, yeah, that's fine, maybe pi ln squared 2. I've done a slightly mistake, I think. I've mistaken somewhere. Wait a second. When you replace here 2, when you plug 2 here, so that's gonna give us negative 1, and 1 minus 1 over 2 is 1 over 2. So pi squared 2. Wait a second, guys. I think I messed up here. Because if we talk about this Dirichlet of eta of 2 pi squared over 6, and oh, that should be negative pi cubed over 6, I think. And I think I just made a mistake here. I'm not sure about that. Oh, wait a second, guys. Let me just have a look at this, what I have done here. Oh, I'm so sorry, guys. I'm so sorry. Actually, everything was right, but I have written wrong inside my notebook. The final answer, I wrote that down wrong, and that was actually correct. So finally, everything was right. So finally, we are having our I equals minus pi cubed over 6 and plus pi ln squared of 2. How amazing is that? Like, that is literally amazing. That is good. That is very good. Or maybe we can write that down as I equals pi ln squared of 2 minus pi cubed over 6. So yeah, that was the integral, and I think I took a lot of time, but I made sure that I have to just make you understand everything, every step, each step, so that you would in future, if you find something like this, so you don't get messed up. And yeah, each step just taught us a lot. And this is my first video in which I have talked about Dirichlet Eta function, and yeah, maybe I will be proving that the Dirichlet eta of S equals 1 minus 2 to the 1 minus s and times Riemann zeta of s. That's a fantastic relation in which we are relating the Dirichlet Eta function with the Riemann zeta function, right? So yeah, everything went right, and I think you got to know a lot of things, and if you did, thank you so much. Thanks so much for watching this video. That was great, and yeah, if you are finding any sort of problem with me, so please just tell me in the comment section, and I will really improve that. And yeah, thank you so much for watching this video, and stay tuned for the next video. We'll meet with the proof of that interesting thing. So yeah, goodbye. Have a good day or good evening or good afternoon and good night. Thank you so much. Goodbye. That was the Truman Show.